Right now, someone in Fargo, North Dakota is probably standing outside in 81-degree weather, just watching this hazy, vivid red sunset.
Yeah, and they probably have absolutely no idea why it looks like that.
Right. What they might not realize is that the unique colors painting their sky are, well, they're the direct result of a pine forest burning to the ground over 1,000 miles away in Washington state.
That's incredible how that
It
works.
really is. So, welcome to this deep dive. Today, we are unpacking the Daily Tech Reader's comprehensive U.S. weather report for Tuesday, August 11th, 2026.
And this isn't just your standard weather update, right?
Exactly. Our mission isn't just to read off a list of daily highs and lows. The goal is to unmask the massive invisible gears turning in the atmosphere right now, showing you how energy displaced in one corner of the continent actually dictates the reality for someone living entirely across the country.
I actually have a massive glowing digital meteorological map of North America pulled up right behind me today. And looking at it in totality, the concept of state borders completely vanishes.
It's just one big interconnected system.
Exactly. You don't see isolated weather events. You see atmospheric physics in constant fluid motion. I mean, every system is reacting to the physical presence of the others.
So whether you are traveling for business this week or managing a complex logistical supply chain or, just trying to make sense of the extreme sky outside your own window, understanding these interconnected systems is your shortcut to being truly well-informed today. Okay, let's unpack this.
Sounds good.
The best way to understand today's map is to view it through the lens of displacement, right? The energy dominating the western half of the country is basically forcing a massive atmospheric reaction in the eastern half.
Right. And the engine driving that initial displacement today is a relentless high-pressure heat dome. It is just parked over the west and the south.
So talk to me about the scale of this thing.
Well, to understand the sheer scale and really the mechanical force of this phenomenon, you have to picture the atmosphere in 3 dimensions.
Okay, so looking up.
Yeah, exactly. This heat dome is essentially a sprawling mountain of high pressure miles above the surface. The air inside that upper level system is incredibly dense and, gravity forces it to sink toward the ground.
And as it sinks, it heats up.
Right, precisely. As that column of air sinks, it undergoes a process called adiabatic compression. Basically, basic thermodynamics dictates that compressing a gas causes its temperature to rise.
So it's pushing down and heating up at the same time.
Yep. So the sinking air acts like a literal lid on the atmosphere. It suppresses any cloud formation, allowing intense solar radiation to just bake the surface, while the air itself is actively heating up as it compresses downward.
And man, the resulting numbers in the desert Southwest are just staggering. I mean, Las Vegas is sitting at 112 degrees today.
Wow.
Palm Springs and Yuma are at 113, and Phoenix is pushing 115 degrees.
Those are incredibly dangerous temperatures.
They really are. But digging into the daily report, the daytime highs only tell half the story. The forecast explicitly notes that the overnight lows in Phoenix are barely dropping into the low 90s.
And that is the real killer.
It's like we are looking at an environment functioning like an oven that never actually turns off between meals. The kitchen just gets hotter and hotter because the thermal energy compounds day after day.
What's fascinating here is how the physical infrastructure of a city collides with this meteorological setup.
Like the concrete and everything.
Exactly. The lack of overnight recovery is the primary driver of heat-related mortality. Because human physiology, while it relies on a nocturnal temperature drop to shed the thermal load accumulated during the day.
We need to cool down to survive.
Right, and in Phoenix, you have the heat dome trapping the infrared radiation that the Earth naturally tries to release back into space at night. But you also have the urban heat island effect.
All that pavement just soaking up the sun.
You've got thousands of square miles of concrete, asphalt, and steel absorbing that intense 115-degree solar radiation for 14 hours straight.
Wow.
So after the sun sets, that immense thermal mass slowly bleeds the heat back into the air. It keeps the surface temperature artificially inflated.
So the environment completely strips away the body's ability to reset.
Yes, completely.
This fundamentally explains why Clark County is rushing to mobilize cooling stations and why the National Weather Service is stressing the urgent need for wellness checks on vulnerable populations today.
It's a true emergency. And because the atmosphere is a fluid system, this dome is not confined to just the desert.
Right, it's spreading. The ridge has expanded its footprint, stretching its influence deep into Texas. Like Dallas and Fort Worth are registering ambient temperatures of 100 degrees. But with the Gulf humidity trapped underneath that high-pressure lid, the heat index is actually spiking to 107.
It's incredibly oppressive.
And we even see this pushing north into the Mountain West. Denver is flirting with the 100-degree mark today.
Which is wild for Denver. This broad expansion really highlights the stubborn nature of a blocking pattern.
What do you mean by a blocking pattern?
Well, the jet stream, right, the upper-level wind current that normally ferries weather systems from west to east across the continent, is being forced to reroute entirely around this massive high-pressure mountain.
It just hits a wall and goes around.
Exactly. It locks the regional weather into a stagnant holding pattern for weeks at a time. And the cascading effect of a blocking high parked over North and Central Texas is severe dehydration of the local ecology.
The plants just dry out completely.
Yeah. The sinking, compressing air pulls moisture out of the soil and vegetation at an accelerated rate. This rapid desiccation creates the elevated grass fire risks highlighted in today's report.
So it's basically building a tinderbox.
Right. When the humidity drops even further later this week and the winds increase, that entire region becomes highly combustible.
And that concept of combustibility brings us to the West Coast, where this stagnant air mass is fundamentally altering the landscape too. But it's also generating some of the most extreme geographical contrasts on the continent.
California is a perfect example of this today.
Yeah, in California's inland Central Valley, the heat is absolute. Redding is pushing 108 degrees, and Fresno is at 105.
Brutal.
But then, less than 60 miles away, San Francisco is completely insulated. It's sitting at a cool 62 to 63 degrees under a dense marine layer.
The contrast is just amazing.
It's crazy. I want to dig into the physics here, because you have a 40-degree temperature drop inside an hour's drive. It's literally like walking out of a dry sauna directly into a walk-in refrigerator. And the inland heat isn't just ignoring the coast, right? It's actively sustaining that coastal cold, isn't it?
It is, yeah. It is a perfect self-sustaining thermodynamic loop.
How does that work?
Well, the ocean water flowing down the northern California coast originates in the Gulf of Alaska via the California Current, making it exceptionally cold. This dramatically chills the air immediately above the ocean surface.
Okay, that makes sense.
Meanwhile, you have this intense compressing heat baking the Central Valley. Hot air expands and rises, which creates an area of localized low-pressure inland.
Which effectively creates a vacuum.
Yes.
The low-pressure inland actively pulls the heavier, denser cold air off the Pacific Ocean toward the landmass.
That is the exact mechanism. The marine layer gets drawn tightly against the coast by the very heat it's contrasting.
That's wild.
You then have a temperature inversion. The hot air aloft acts as a ceiling, while the coastal mountain ranges act as a physical retaining wall, basically trapping that dense, heavy fog directly over San Francisco Bay.
So they're just stuck in the cold.
Right, and the Central Valley continues to roast just a few dozen miles east, pulling the marine layer even tighter against the coastline as the day progresses.
But while San Francisco benefits from that localized thermodynamic loop, the Pacific Northwest is entirely exposed.
Yeah.
Moving north of that protective coastal geography, the map reveals a pretty dire situation.
It's very bad up there.
Portland is at 87 degrees and aggressively dry. And moving east to the Cascades, Spokane is dealing with active, massive fires like the old Trails Fire Complex.
Yeah, that one is moving fast.
The air quality has deteriorated so rapidly that Washington Governor Bob Ferguson has declared a formal public health emergency.
The northern periphery of our central heat dome has basically settled directly over eastern Washington and Oregon. The forests in these regions are biologically adapted to dry summers, sure, but the persistence of this blocking ridge has just accelerated the drying of fine fuels.
Like the brush on the ground.
Yeah, the pine needles, the underbrush, the dry grasses, the fuel moisture content has plummeted to critical levels.
Which makes fighting the fires nearly impossible.
Exactly. For the crews battling the old Trails Fire Complex, this means the fire behavior is explosive. Furthermore, the stagnant high-pressure air prevents any meaningful atmospheric ventilation, which traps the toxic smoke in the valleys where the firefighters are operating.
Here's where it gets really interesting, though. We often conceptualize wildfires as hyper-local disasters, but the report outlines a transcontinental smoke highway.
The smoke never just stays put.
Right. The consequences of those Pacific Northwest fires are currently deteriorating air quality across Idaho, Montana, and Wyoming. Like Boise is sitting at 92 degrees under a red flag warning, choked by heavy smoke.
And Billings is getting hit hard, too.
Yeah, Billings, Montana is at 97 degrees with similar impacts.
This is where the vertical profile of the atmosphere becomes really crucial. A high-intensity wildfire generates an immense amount of convective energy.
It pushes air up.
Right. It creates its own powerful updrafts known as thermal columns. These can punch thousands of feet into the troposphere, breaking right through any low-level temperature inversions.
Wow, just blasting the smoke straight up.
Exactly. And once the particulate matter reaches those upper altitudes, it interacts with an entirely different wind regime than what is actually happening on the ground.
It gets caught in the westerlies.
Yes.
And we can see a localized version of that wind shift playing out in Seattle today. The city is finally getting some relief, sitting at a nice 82 degrees, because the surface-level westerly winds are pushing the worst of the smoke away from the I-5 corridor.
Which is great for Seattle.
Right. But Seattle's localized relief is essentially everyone else's problem out east. It's the mechanism initiating the transport of that smoke eastward across the interior of the country.
The upper-level winds basically function as a high-speed transcontinental transit system. The jet stream grabs the smoke lofted by those massive thermal columns and just carries it across the continental divide.
Which brings us back to our listener in Fargo, North Dakota, observing that vivid sunset at 81 degrees.
Full circle.
Exactly. The report explicitly notes elevated wildfire smoke from Washington state over 1,000 miles away, yet forecasters make a strict distinction here. Fargo isn't experiencing the widespread surface air quality impacts seen in Spokane.
Right, they can breathe just fine.
The smoke on the ground in Washington is floating miles above the clouds in the Dakotas.
That's because the smoke over the upper plains is cruising at the altitude of commercial aircraft. It's residing entirely above the planetary boundary layer where our daily weather occurs.
It's a way up there.
Way up there. And because it remains aloft, it undergoes a process called scattering.
Scattering.
Yeah. Basically, the suspended particulates scatter the shorter wavelengths of sunlight, like the blues and the greens, allowing only the longer red and orange wavelengths to pierce through to the observer on the ground.
Ah, so that's what makes the sunset so red.
Exactly. It dramatically alters the optics of the sky without compromising the breathable air at the surface. Spokane, being immediately adjacent to the ignition source, is trapped inside that boundary layer where the smoke is initially produced and settles heavily overnight.
That makes total sense. So we have tracked the displaced heat and the displaced smoke, but eventually that massive stagnant air mass dominating the west has to end.
It can't go on forever.
Right. That heat dome cannot expand indefinitely. It inevitably hits the cooler, denser air currents dipping down from Canada, which is the exact collision zone generating today's severe weather threat in the Midwest.
And this is where things get violent. The boundary between two vastly different air masses, which is called a baroclinic zone, is where atmospheric volatility reaches its absolute peak.
And we are seeing that peak today.
Oh, yeah. The Storm Prediction Center has highlighted an enhanced risk of severe storms overnight for the upper Midwest. This specifically encompasses South Dakota, southwest Minnesota, and northwest Iowa.
And the atmospheric profile there is primed for a highly organized system, right? A mesoscale convective system, or MCS.
Yes, an MCS.
The daily report warns of a, quote, bowing MCS moving through that region, carrying the threat of large hail and 75-mile-per-hour wind gusts. The terminology bowing refers to the radar signature, where the leading edge of the storm line physically pushes out faster in the center than on the edges.
It literally looks like an archer's bow on the radar.
Right. So what mechanical force is driving the center of the storm forward at such destructive speeds?
Well, the physical process creating that shape is driven by a phenomenon called a rear inflow jet and the resulting cold pool.
Okay, break that down for us.
As these massive thunderstorm clusters mature, heavy precipitation falls through a layer of dry, mid-level air. The rain evaporates rapidly, which drastically cools the air around it.
Because evaporation is a cooling process.
Exactly. Cold air is significantly denser than warm air, so this massive column of chilled air plummets toward the surface. When this immense downdraft hits the ground, it has absolutely nowhere to go but forward and outward.
Like dropping a water balloon on the floor.
Basically, yeah. It acts like a wedge, physically accelerating the center of the storm line and generating those destructive 75-mile-per-hour straight-line winds that bow out the radar signature.
And that boundary of volatile energy is progressively sweeping eastward through the day toward the Great Lakes and the Ohio Valley.
Chicago is definitely in the crosshairs.
Yeah, Chicago is looking at a high of 83 degrees today. But the primary threat highlighted by the National Weather Service isn't the wind. It's actually a slight risk of excessive rainfall and flash flooding.
which is highly concerning.
And to really grasp this threat, we have to look past just the precipitation rate of the incoming storms and examine the specific soil hydrology of the region.
This raises an important question, right, about how modern infrastructure handles natural watersheds. We are dealing with heavily saturated clay-rich soils across the Chicago metro area from previous rain events just this week.
The ground is already soaked.
Yeah, it has reached its absolute maximum absorption capacity. So when you combine soil that physically cannot infiltrate another drop of water with the immense square footage of impervious surfaces in a major urban center.
The concrete, the asphalt highways, the sprawling rooftops.
All right, you fundamentally break the natural drainage equation.
So every drop of rain from this advancing front instantly becomes surface runoff.
Every single drop.
The municipal drainage infrastructure and the deep tunnel systems are just forced to handle the entire volumetric load of the storm simultaneously, which drastically elevates the risk of urban flash flooding.
The incoming weather basically ceases to be just a meteorological event. It becomes a real-time infrastructure stress test.
So what does this all mean for you if you are living on the East Coast waiting for this front to finally arrive?
It means you are waiting in a pressure cooker.
Exactly. The Northeast and Mid-Atlantic are effectively trapped in a pressure cooker ahead of the collision. New York City and Washington, D.C. are baking at 91 degrees, with the humidity pushing the apparent temperature in D.C. well over 100 degrees today.
It's miserable out there.
Philadelphia is sitting at 92 degrees. Millions of people are enduring a stifling prefrontal air mass.
The timing of the frontal passage is the critical variable for the I-95 corridor today.
Because that's when the storms hit.
Right. A severe thunderstorm watch is active through the evening for portions of New Jersey, Delaware, and suburban Philadelphia. The severe threat will materialize precisely along that advancing boundary line.
As the cold air meets the hot air.
You have the incoming cooler, denser air physically bulldozing the oppressive, muggy air upward, which triggers explosive, rapid convection right along the front line.
But the contrast post-front is dramatic. Like, looking just a bit further north, Boston already experienced this frontal passage on Sunday.
And they're feeling great today.
Yeah, they are enjoying a highly comfortable 79 degrees with mostly sunny skies. So the atmospheric relief is clearly on the map. It just requires a turbulent transition period for the major tri-state metros to actually get there.
They just have to get through the storms first.
Right. But while the entire northern half of the country is defined by this volatile west-to-east continental collision, the southeast is facing an entirely different hydrological threat today.
A very slow-moving threat.
Yes. A sluggish system marching out of the Gulf of Mexico is rewriting the regional forecast. We are tracking Tropical Storm Bertha. As of Tuesday evening, Bertha is positioned about 130 miles west-southwest of Panama City, Florida, moving west-northwest.
And the metrics on Bertha present a highly specific, insidious type of danger. We are looking at maximum sustained winds of 60 miles per hour, but a forward speed of only 6 miles per hour.
New Orleans is currently at 88 degrees, and the entire metropolitan area is blanketed under a tropical storm warning.
Everyone is on edge there.
Yeah, Louisiana Governor Jeff Landry issued a statement confirming that over 90% of the city's major drainage pumps are fully operational. But looking closely at the threat profile here, 60-mile-per-hour winds, while hazardous, do not typically prompt the level of infrastructural anxiety we are seeing from local officials.
Not usually, no.
Bertha is moving at 6 miles per hour. That's practically a brisk walking pace. Why are places like Baton Rouge and Mobile on such high alert for a storm moving that slowly with only 60-mile-per-hour winds?
Well, if we connect this to the bigger picture of tropical meteorology, a slow forward speed is arguably the most destructive characteristic a system can possess regarding water impacts.
Wait, really? Slower is worse.
Much worse. The lack of upper-level steering currents allows the storm to just meander. The Gulf of Mexico has exceptionally high sea surface temperatures right now, providing a limitless fuel source of latent heat and moisture.
So it's just drinking up the ocean.
Right. And when a system only moves at 6 miles per hour, it continuously siphons that marine moisture and deposits it over the exact same localized geography for days on end.
The storm essentially parks over the coastline, which drastically compounds the precipitation totals and extends the duration of the storm surge.
Exactly. It maximizes the hydrological load on the coast. The prolonged onshore winds continuously push water into the coastal bays and estuaries, generating a sustained storm surge of 1 to 3 feet that prevents normal tidal drainage.
So water just can't drain back into the ocean?
No, it's blocked. And for a topographical bowl like New Orleans, which sits below sea level and naturally experiences subsidence, managing the sheer volume of continuous, relentless rainfall is an existential challenge.
So the pumps are literally life or death.
The operational capacity of those drainage pumps isn't just a political talking point. It is the sole mechanical process keeping the urban basin from filling up like a bathtub.
And the atmospheric reach of Bertha extends far beyond the immediate Louisiana coastline, right? Houston is baking at 97 degrees under the western edge of our continental heat dome. But the tropical moisture bleeding off of Bertha's outer bands is actively infiltrating East Texas.
The air is just incredibly thick there right now.
It is combining with the ambient heat to push Houston's heat index well over 105 degrees. The immense humidity generated by a Gulf storm is rendering the heat dome in Texas exponentially more dangerous.
But on the opposite flank, the Florida Panhandle is experiencing the inverse effect.
Because the storm is moving away from them.
Exactly. Pensacola is sitting at 85 degrees, and their local conditions are steadily improving. The slow western progression of the storm is gradually pulling the deepest moisture away from their longitude.
So a single sluggish tropical system acts as the atmospheric pivot point, dictating the comfort and safety of the entire Gulf Coast.
It dictates everything down there today.
The sheer scale of this machinery is just awe-inspiring. By stripping away the borders on the map, you can trace the exact physics connecting a 115-degree urban heat island in Phoenix to a 62-degree fog bank in San Francisco.
It's all connected.
You map how the thermal columns of a burning forest in Washington state utilize the jet stream to paint the sunset in North Dakota, and how the slow, churning thermodynamics of a Gulf storm dictate the heat stress of a population all the way in Houston.
Seeing it all together completely reframes how we interact with our environment. The underlying thought you should take away from analyzing today's map is how these massive, continent-spanning mechanisms challenge our localized view of the world.
We tend to just look at our own backyard.
We do. But in an era of shifting climates and increasingly dynamic extremes, relying on a simple, isolated icon on a local weather app is an incomplete strategy.
It gives you the temperature, but it completely strips away the context of the system.
Exactly. If a high-pressure ridge in the desert can dictate the flash flood risk in Chicago, and a tropical storm can shift the humidity index a state away, we have to conceptualize the sky differently.
It isn't just a static canopy draped over our individual neighborhoods.
No, it is a shared, continent-wide fluid. A thermodynamic disruption in one corner inevitably creates ripples that wash over us all.
A shared, continent-wide fluid. The invisible gears are always turning, and understanding how they interlock is your best tool for navigating the week ahead. Thank you for joining us on this deep dive into the Daily Tech Reader's Weather Report. Keep your eyes on the horizon, and we will catch you next time.